So what I've been thinking about is, like, we've all been using agents to generate code, right? More and more over time. And this is a good trend. We must do it. The tricky thing is, as you start to use agents to generate more and more, and I'm thinking more in the software development space, but I think this applies to an ML area, ML ops areas, and others. It's all about writing code, right? You start with some kind of architecture, this sort of zoomed out architecture, and you say, this is how it's going to work. We're going to have stuff on the left flowing in, doing things in the middle. We're going to create these distinct layers throughout our application. And we start out very carefully laying this architecture down, and generally that's okay. But what we find is, maybe over time, and certainly my experience, as you get agents to work inside this environment more and more, they start to tend to blur the layers of that architecture. And so what I've been thinking about is, how do you prevent that from happening? How do you create like really strong constraints in your architecture that when agents do work within it, it is very hard for them to break those layers down. And so they would tend to stay within those layers. And I think that's a good thing for like long term. I'm not thinking about one-shotting out an application. I'm thinking about an application over time. So over, I don't know, a 2 or 3 or 5 or 10-year lifetime of an application, agents working in it over time, how do they stay respecting the architecture of that application? Okay, so this is the problem, I think. Agents are architecturally blind. And what does that mean? It's, of course, you can inform an agent of the architecture. You could write an agents.md or some kind of markdown file and tell them about the architecture. And that's okay. But typically, like, your code base doesn't reflect the architecture until you understand the code base almost in its totality, right? It's hard to extract actually an architecture out of a code base. It's a difficult problem. It's not clear. There's no single file like architecture.java or something which defines the architecture of your application. It tends to be more defined through conventions and someone reviewing the code, figuring out what those layers of your architecture might be. The second thing, which I think is quite interesting, is that side effects are invisible. So what are side effects? Side effects are where your code makes changes to the world. So you have a program that does stuff, like it connects to a database, it writes to the log, it calls some other API. So side effects are things that where your code base makes changes that are outside of the bounds of the software itself, if that makes sense. So if you think of your program is typically quite a static thing, it doesn't generally hold state inside it. Some bad software can, but typically it doesn't. But it makes changes to the outside world. It updates a database or reads a database or writes to a log or whatever it is. Those are called side effects. We'll get into this in a little bit more detail, because I think the core of solving this first problem is solving the second problem. So making your side effects visible in your software helps your agents understand your architecture better. And then the last part, context window. So of course, we're dealing with context window size, and maybe this will be something that will be solved over time, but an agent can't load necessarily a large code base into memory and therefore then understand the architecture. So it has to sample bits of your software to understand what the architecture looks like. Okay, so that's like the problem. So what are effect systems? So my whole view here is that by defining effects in your code, so by surfacing effects in your source code, what changes to the world can this function make? We start to make more visible the layers of the architecture of your application. Like, if you can see very clearly in your code, by looking at its functions, by looking at its signatures, which parts of your code base update the database, which parts of your code base call external APIs, which parts of the code base, I don't know, verify a JWT token, without going and reading all of the code, this brings architecture into your code base. And I have to apologize over and over, but I love Haskell's a great language. It allows you to do this. Other languages make this much more difficult to do. And so I've specifically chosen to not use a difficult language to reflect this idea, but use an easy language to reflect this idea. But let's understand this type signature. quickly. It is Haskell, and I know it probably hurts your eyes to look at it, but it's actually not that complicated. So this is just a signature for a function. It's not the function itself. It's just saying there is a function called fetch user, which takes a user ID. So this could be some kind of like alias or structure, something that reflects a user ID. It's just a well name. It could be an int, but it's been given a name, user ID, and what it returns, the user. Then let's understand this EFF ES thing. It's just saying this function also causes some effect, some change to the world, or it reads the state of the world. And those are a user repository. So it makes use of a user repo. So if you were writing a lot of code, there's this thing called the repo pattern. You would probably say, okay, so this is a database. This thing accesses the bounded context of user within the database, which could be anything. It could be a S3 file, it could be a SQL, it could be a MongoDB, whatever. It's some kind of user repository object. So it makes use of that, and it also makes use of logging. So when you look at this function, and these things are called constraints, by the way. So it's saying the effects here, in order for it to get us a user, the constraints that this function requires is it requires a user repository to be available to it, as well as logging to be available. It cannot do this with anything else. So these are not, this is not it being friendly by telling you what it may use. We are limiting this function in that it can only use these things, if that makes sense. So by looking at this function, fetch user, you can see, okay, this, and it can do nothing else. It can't write to standard out. It can't read a config file. It can't speak to any other part of the database. It can't make an API call to some, I don't know, security service or whatever. This function is completely constrained by these effects. I don't know what your thoughts are, but that is a very powerful thing, actually. Like fetch user can only work within this like set of hugely constrained things. So it can get us given a user ID, it will return a user, and it will only ever talk to a database and generate and talk to some logging capability. Very powerful. The cool thing here, and certainly this is in, because you might say in C# or something, okay, but I could use, what is it, dependency injection. Like I could inject these objects into this function and through some sort of interface and make use of these things that way. And I would say, yes, of course you could do that. The problem is that's not enforceable, right? We can't enforce that you stick to that convention. In a language like Haskell and with effect systems, it's like, this is fully enforceable. There is no other, this function cannot write, it cannot cause any other side effect. It is not possible. It's a pure function, effectively. Okay. Any questions on what are effect systems in? So that's like literally like what effect systems are, is the ability to write a function where you make visible what effects you cause in the world. Any questions? I know it's weird, but you can imagine that what this does, right? Yes.
Tom, I've got a question around just about, so it's difficult to get agents to comply with an architecture because the architecture is embedded in the thinking in the code. So I guess my position would be, it's also really difficult to get humans to as well. As someone who's tried to get alignment from devs in architectures for decades, I know it's really hard. As a dev, I don't want to align with some painful thing when I can just build it and make it work in the way that's most harmonious with my own thinking, rather than aligning my thinking with somebody else's thinking. So have you thought about an adversarial agent model where one of the agents has memory of what the architecture is supposed to be and has context of just the architecture that adversarially reviews the work that's output by other agents?
For sure. Yeah. And I think that's probably probably today, that is the approach you should take. In my view, and this talk is, I think the compiler is that adversary, is that adversarial element. The compiler, because when you compile this program, the compiler makes sure that any implementation of fetch user abides by these constraints. And I would say that is the ultimate adversarial thing. So an agent working with a compiler that will not allow code to pass these constraints and that's not an agentic thing. It's not an intelligent thing. It's a purely mechanical thing. And isn't that kind of cool? Okay, but we'll get there.
No, cool.
So here's a little worked example. Okay, yeah. So this is just showing you now an implementation. So here's that function signature. How may we implement this function, fetch user? And I know squint your eyes at the syntax, but it's really easy to understand. Here is the function implementation. It takes a user ID as its input. This is that user ID up there. This is just its name. And it's like, you can imagine that this code is just like any other code. It starts at the top, does stuff top to bottom. That's not always a given in Haskell, but this word do tells you that. Here we can see we call log. So we log the string fetching user. And it's like, that's fine because we said we relied on logging. We needed logging. So we're allowed to call log. We go and fetch. So now we're calling lookup user. This is obviously a function visible inside this like user repo thing, lookup user. And we pass the user ID to that function, user ID. And we get back the actual user. This is like an equals. Imagine this is like call lookup user, but imagine this backwards arrow is more like a dot then, like a deferred or an async, because we're going to get it after some time. It's not a blocking call, but like an async call. Think of it in that way. That's what the back arrow seems. But then, of course, that lookup user could fail, right? That user might not exist. And so that's what this next piece of code is doing. It's saying, what is this user thing we got back? If we got back nothing, then something needs to happen. If we got back a user, then great, let's return that user because that's what we said we'd do. We're returning a user, and that's fine. The question that I wanted to show here is, okay, in the case where this user doesn't exist, what would we normally do? And this function doesn't return a possible user. It says it returns an actual user. And so we have to give it back a user. And if you're thinking of, I don't know, like most code, Java or C# or others, what you might want to do here is throw an exception or something, or fail in some way, crash the runtime, I don't know, do something. Interestingly, though, in this example, there is nothing we can do. We have no ability to throw an exception because that is a change of state. We have no ability to crash the app because we haven't passed through some effect of crashing the app here. So in fact, as I'm implementing this function as an agent or even as Tom, I go, oh, actually, there is something missing in this function signature. Like there was some other effect I'd forgotten to put here because I don't know what to do here. And so the answer possibly is, oh, I actually do need to be able to generate errors or throw exceptions. And so I need to go and add and make visible the constraint that this function also can fail. And so I add this here, error of type string, and now I can call a function like throw error and pass some string to it. And that would generate something like an exception in here. And so what we've actually ended up doing is like refining this fetch user function. Just through the implementation, we've realized that actually we had missed a few ideas. Yeah. So anyone calling this is also then forced to deal with this error situation. Do you know what I mean? That kind of makes sense? Yeah. Okay. So the anatomy of effects. So these are called effects. What do they look like? There's just two parts to it. It's very simple. And it's not important that you understand this, but it's important that you understand the two parts of it, because the next part I'm going to talk about deals with this. So the first thing is you define them in some way. You say, what are the possible effects of this kind of thing? So you define a new type of effect. I'm calling it my effect. And it has a list of things you can do with my effect. It's like an object. Think of a class. I create a class called my effect, and I create a bunch of, what do you call them? Like abstract methods on that class. Do something. A do something method takes a sum input and it returns a sum output, but it's wrapped up in this my effect type. It's not important to understand that, but it takes some input and returns some outputs. And you can create many like abstract methods like this. You could have a do something and a do something else and a do a third thing. All fine. Different inputs, different outputs. It doesn't really matter, but you bundle them up and then you say, I've got this my effect type. So a database repository, like the user repo may have a fetch user, a get user by ID, a get user by name, update user, delete user, whatever, right? Link user to other user, all the functions that you would want to export from that user repo, you define them there. And this is just at a definition level. So you're just designing them here. You're not implementing them here. You're just designing them. Then what you do And so these are just data structures. It is just data. The effects themselves are just data constructors. They have no functions or algorithms associated with them, right? They're just like specifications in terms of schema. They're like schema. But then, of course, you've got to implement them. And this is called, in the effects world, implementing interpreters. You've got to be able to interpret these effects when you want to actually implement them. So when you want to say, what does the do something actually do? You implement what is called an interpreter. I actually don't put that in here. And that interpreter, what it does is it takes the effect with a constraint that has this my effect in it, and it effectively returns a constraint where it returns the effects that don't have that thing in it. So it's effectively eliminating that effect from the type system. So if you imagine these effects are like layers of an onion, you may have, if we looked at the previous example, fetch user wraps itself in a user repo, a logging, and an error. So when an interpreter runs, and it's the error interpreter, it gets this function, it runs the error parts of it, and it takes it off, returning a function which just has the last two things remaining. So you would run these interpreters in order and strip these effects off of the function as it runs. Just trying to give you some intuition of how this works. And in that signature there, you can see that. Kind of, you can imagine that this is pattern matching and removing the constraint there, returning it in it, returning the remaining list of effects. The other, and so that's called that's eliminating the effect. The other very interesting part, and this is the most important part, is that your interpreter can, yes, eliminate them, but it can also introduce new effects into that list. So it's exactly the same thing. It's like remove the my effect from the incoming list of effects, but then return an effect ES where we've added logging back into it. So it's like I've taken off a layer and I've put a new layer around it. Okay. So how is this useful? Okay, so now we know what effects are. It's fine that you don't really, but you try and like conceptually understand it. Maybe this doesn't map nicely to Python or Java or others, but maybe it's a bit weird and tricky to think about. Okay, so how is this useful now back into that architectural problem we had in the beginning? So I'm just thinking of like an API for a backend, right? I'm building an application, it does some stuff, it talks to a database, maybe it sends a few emails and it calls a few external APIs. How may it be architected? Like a very simple backend, a backend like an API, right? This is how you may structure it. You may say, I've got a list of handlers. These are like methods that take, I don't know, get, post, put, and delete requests to update stuff. Some of those calls may be quite complicated and they may need to do various things. In other architectural patterns, you might say these are things like sagas or workflows or use cases, orchestrations or whatever. That's fine. So APIs generally should call into orchestration. Those orchestrations typically should work with domain objects or bounded contexts or something. And so you'd have all your business rules at this like domain layer. Those business rules, though, at some point need to make changes to the outside world. And normally you would create like abstract interfaces for those external things like the repo pattern and other things. And those things actually talk down to real infrastructure like a database or send an email or integrate with external APIs or talk to S3 or whatever it is, right? And so typically I would say that's a good starting point for the layers of a backend for a medium to large sized backend API, right? Do those kind of make sense? I think you'll get different flavors of this. If you're in the .NET world, I think there's like the MVC pattern is quite common, or MVVM, things like that, or effectively are trying to create these, you know, various layers within your architecture. I'm not saying this is the perfect architecture. I'm just saying this is one such architecture. Yeah. The problem with this is, from an agentic perspective, is like you can go and create all these layers, but your agents and your humans, as Anthony said earlier, are completely free to step outside of, go and do whatever the hell they want. So you may find over time that you have examples where you've got API handlers that are maybe calling directly into your infrastructure. Like, why not? There's nothing stopping you in your API handler code connecting straight to S3 and reading a bucket and returning it. And so you may find that. You may also find your API handlers, instead of working through these like use cases or orchestration layers, may just call the domain objects directly. And that's like that one there. So we'll just skip a layer because it's easier. Another thing might be that like maybe you're in your domain layer, instead of working through these abstract interfaces, why don't we just call the infrastructure directly? And so maybe you would end up skipping things. And I think there's like a million examples here. And when you look at this, you say, okay, this is spaghetti, right? This is how you create spaghetti. Things don't flow through the layers. They call all over the place. And I think agents and humans, as Anthony said earlier, certainly have a tendency for this to happen, right? So what can you do now that you know what effect systems are? What you can do is you can encode those layers in terms of interpreters, and you can guard that things have to go through through the layers. There is no way for stuff to break out of the layers. And so I don't need you guys to understand this, but like what you could do is up at your API handlers at that first layer where requests come into your system, it's like you build an interpreter that governs the next layer that those handlers have to use. They have no ability to step outside. Like they're going to run through a set of interpreters that are going to strip off the effects that they use and rewrap with the effects that the domain layer can use, if that makes sense. So it's like you take off stuff at this layer. So the API handlers can only use maybe domain objects. And so they would strip them off. Those domain objects can only use infrastructure objects. And so you put those back in effectively. What I'm proposing is that you could go from that 5-layer architecture previously to 3 layers, but with 2 interpreter layers in between for that particular example. And what this ends up creating is like those 5 layers of the onion, but where the software is wrapping and unwrapping those layers, and the compiler is enforcing it as well. Okay. We've got very little time left, so I'm not going to go through the way effects taint. This is just, effectively, it's telling you they are forced upon you. You cannot, they taint. So this is the same way that in Java, when you call code that uses exceptions, you have to also throw exceptions. You have to define those. So that's what tainting is. The big benefit here, though, for me, is your compiler becomes a co-pilot. So as your agent is writing code and it is maybe not honoring the layers of your system, the compiler is going to stop him. And not to stop him from doing his work, but that compiler is going to inform the agent of the architecture as well. So when that first error appears and it says to the agent, hey, you can't call infrastructure because actually you're at the API layer, you have to call domain objects, the agent will go, oh, I didn't realize that. Got it. Thank you. And puts him back on track. So he'll then figure out what he needs to do and he needs to implement it in the domain layer, right? So I think the important point here is that your types become this kind of dense specification of your architecture. The other very cool thing is they're tiny. And so you can have almost your entire system set of constraints in possibly a single context window for every layer without having to understand the implementation of that code. They're all sitting at the signature level. Okay, that's kind of it. There are libraries to do this. Haskell does this extremely well because you get the compiler able to do this enforcement. However, of course, in weaker languages out there, TypeScript, Scala, Python, and all others, there are implementations of effect systems which do this. Of course, they can't prevent bad code being put into an architecture the way Haskell and a few others can, but there's certainly a good way of helping communicate effects to agents. So I gave an example of a Python library, a TypeScript library, and then there are some languages out there like Coca and Unison, which have taken this idea very seriously and have built it into the core of their system. So in fact, for example, Unison has a thing called abilities, which is part of the core language where there is no way to cause any side effects within Unison other than through an effect interface. And so it's a first-class language feature for Unison. That's it. Yeah, that's the end. There's a few other links here if you're interested in other, what would we say, like similar ideas, maybe around more like program synthesis. So once you start to define things within signatures, you may even ask yourself, but if I knew all of this, if I know that this function, get user order history, uses these three effects and must return this order thing, maybe I could synthesize without even my agent writing the code. Couldn't I just synthesize the answer to this function? And there's a bunch of interesting research going on around that exact topic, which is called program synthesis. Some cool things to go look at is CHOP, HYSynth, and SubGen, which are trying to brute force or use agents to generate and synthesize programs that match function signatures, which I think is super interesting. That's me. Any questions?
I had one. I dropped it in the chat because I think we're going to have to drop off now. But yeah.
Yeah.
It was basically on your first slide, you said side effects are invisible.
Yeah.
In the function signatures. And that was the main reason for agents being blind to architectures. Are there any other reasons that an agent would be blind? Or any other things that you might seek to address that problem that are not side effects?
You mean what other things make agents blind to architecture?
Or more on the solution end of that. What other things could we use to make our agents less blind?
Oh, I've got you. Yes. Yeah, it's a good question. I'd have to think about it, Bhavesh. In my mind, I feel that it's an 80-20, and the 80 is side effects. Like, I think of when you think of software architecture, it feels to me like what you're trying to do is put side effects at certain layers of your architecture. That, I think, is the primary thing there. I think there's some side benefits. Of course, you want things to be like easier understood and so that they the layers make sense to a human or an agent. And that also feels, and maybe there's some reuse and other benefits. But I think often what you're trying to do is say, there is a part of my program which reads or changes the state of the world, and we need to be very careful about that. And so let's put that in a particular layer. We don't want to have that stuff bleed out all over our application, because as soon as you do that, you have this global state spaghetti nightmare that it's like a database gets updated and later on something gets deleted and you're like, but why did this happen? How is that even possible? And I feel like 80% of the problem here is to solve the side effect problem, enforce that at a particular layer. Or constraining it, I should say.
Agreed. Yeah. Right. Cool.
Anything else? I've got a bit of time. I can hang around, guys. So you are welcome.
There was no mention about Rust. Is Rust not a good language here for effects?
Oh yeah, no, I left it out because I actually don't know. Nick, it dawned on me on the weekend because I know Rust quite well. But I haven't done any looking into Rust and effect systems.
Go and check it out.
My suspicion says probably fairly immature, I think. Yeah.
Thanks.
But I don't know. Yeah. It's a very strong compiler, a very good type system. And so I think you could probably do it. It could be very, what is the word, highly terse. Because dealing with lifetimes and types does make for some pretty nasty function signatures. So it could be, yeah, I don't know. I'll look into it. Any other comments? Can I let you go?
I got one. Well, it's a very interesting conversation. You mentioned Unison has been built to the ground up, functional paradigm, and has side effects built into it. Are they building their platform with this kind of concept in mind that your compiler can be a co-pilot, or how does agentic AI fit into their new platform?
Yeah, it's an interesting one, and we were actually very fortunate. Synthesis, we've been watching Unison for a long time, and we know the author quite well. Paul, he's presented to us, Bhavesh will know, and a few others, Archie as well. Chatting to Paul around agents, and this was like a year and a half ago, maybe 2 years ago, when agentic code generation was an interesting new idea. He said the difficulty is that Like the Unison language is not in the body of knowledge that went into certainly the first few generations of LLMs, right? So Unison suffers from the fact that there's not a lot of Unison code out there, very little. And so agents don't generate good code. So he was focused back then on building good MCP tooling, etc., so that you could use a Claude code, plug it into the Unison code manager, have that code manager teach the agent as the code was being generated around what good Unison code looks like. And I think he's been like fairly successful. I think today LLMs are getting better and better. And I think even with very few examples of Unison code, they are generating good code. But the great thing about Unison though, is because you have effects as first-class citizens, even agents generating bad code, it just doesn't succeed. It like has to force itself to learn about effect systems. There is no other way. Whereas in other languages, and even Haskell still has an escape hatch. It's called IO. So if you use the IO effect, I won't use the other word, the IO effect, you can do anything. So as soon as you see the IO anywhere in code, it could do anything. It could write to a file, read a file, delete a file, RM minus RF your whole system, talk to a database, whatever. That's the escape hatch. Whereas Unison has no such escape hatch. It has no general fit-all boundary. You are forced to write every effect as a fully defined effect, which is really awesome. And I do think, I don't know, maybe agents have hit us too early. Unfortunately, the programming languages that are popular, the mainstream ones, are supremely weak and even are difficult for humans to reason about. I would say much worse for agents to reason about. Probably, I don't know, if it was my future, I would say I think we need to change our fundamental programming languages underneath. They are too loose. They don't have enough constraint in them, especially given a world where code is like commodity, right? We can generate 1 million lines of code in a day. Would you want that to be unconstrained? Doesn't make sense to me. Like, I don't think that's a good end result, generating 1 million lines of uncheckable code, even given, okay, more agents can check it. It's okay, but you're like, it's like a slippery, it's like a losing battle, whereas you could use a good language, which has got a whole bunch of constraint checking in it right off of the get-go. And those 1 million lines of code are going to be much higher quality without the ability to break layers. I think that sounds to me like a better future. I think. Yeah, go for it, Devin.
Yeah, I liked that example with the layers, but especially with architectural design, a big part of things is separation of concerns, not just in terms of layers, but in terms of like different business domain, like objects or modules.
Exactly.
Yeah, and sometimes it can be like really hard to decide what functions or what modules should be responsible for doing what. Can these effect systems help constrain those kinds of cross-domain operations and boundaries?
Yes. 100%. Yeah, 100%. I've just shown you an example where we're using effect systems to constrain layers of an architecture. But effect systems are not, they're like a low-level primitive you can use to constrain anything. So you can constrain, that could be horizontally across systems. So from module to module, you might want to define a set of boundaries between those modules. And those are not layers of the onion, but like across, they could be for anything. You could define it even stages of a data processing pipeline. You might say that stuff coming in on the left is like whatever, I don't know, unstructured raw text. But by the time that leaves the first stage of the pipeline, it must look like this. And while it does that, it can only make use of these effects in order to achieve that. So you can start to govern. This is just a low-level primitive that you can use to build whatever kind of architectural constraints you want. It's like an ability for you to encode the architectural constraints into your code base, as opposed to writing it out into a document and then enforcing it through convention and code review. Of saying, okay, but guys, we documented this is how it would work. I'm going to reject this PR because I can see you're doing this wrong here. The problem is that person who wrote and broke that constraint obviously didn't have knowledge of it, but the code worked. And at the end of the day, they achieved the goal. They just broke the constraint. They did it they introduced technical debt effectively into the system. Yeah. Effect systems just allow you to encode that. Okay. I think is super powerful.
Yeah. I guess like the risk would be like knowing what those are up front, those constraint, what they should be, because sometimes you make architectural decisions and then you could constrain those and then realize that it was the different. But I suppose that's the same with any kind of, but that doesn't really change.
Yeah,
and this doesn't really change that.
And if it turns out that those were wrong, you can go and change the encoding, go and add some new effects, but at least you've made it like you've surfaced the decision somehow instead of just breaking it in the code and nobody knows and everyone thinks it continues in the old way. So no, you've surfaced it. You've said, oh no, in this layer we are now allowed to use these effects for ABC reason, and there it is. It's visible. Boom.
Okay, cool.
Yeah. Great question. Yeah. Good insight. Yeah.
Well done, Tom. Thank you so much. As always,
cool, guys.
Very challenging topic.
Yeah.
Nice paradigm to think about. I certainly learned something new today.